we are going to solve two questions from the topic Continuous Random Variables. Please stop the movie and read the question. For each of the following, give the probability distribution function or the probability density function. As I see here in the question A, it's a line. The equation of a line is y equals mx plus c, with m the gradient, so rise over run. 0.7 is a rise, and the run is 3. It's a negative gradient. And c is the y-intercept, which is 0.7. So the equation of this line is y equals minus 0.7 over 3x plus 0.7. In question B, it's also a line with a gradient. I can take for the gradient this as a rise and this as a run. So the gradient is 1. We need to look also at the unit on the y-axis, 1 over 1. Look at the unit on the x-axis, that's on 1. It's a positive gradient. Y-intercept is 0.5. Therefore, the equation of the line is going to be y equals x, 1x or x plus 0.5. And this one is a probability density function. You can write it f of x or y, doesn't matter. Plus 0.5. I need a domain for x between 0 and 1. And 0 elsewhere. Or 0 otherwise. Meaning that for all other x's is 0. In the first case, f of x equals minus 0.7 over 3x plus 0.7 for x between 0 and 3 and 0 elsewhere. Now the second question, which we have here, asks for the probability density functions in the corresponding part, find question A. Probability of x bigger than 2. Well, we'll learn that probability of x bigger than 2 is going to be integral from 2 to 3, because that's where the function is not 0, f of x dx. So it's integral from 2 to 3 minus 0.7 over 3x plus 0.7 dx. But let's take an easier approach. So if you look at the graph, probability of x bigger than 2, it's the area from 2 to 3. So it's this area. So it's going to be the height. So the base is 1, right? So the base is 1. And the height, so AI, the base is 1. Well, the height still looks like 0.2, but I'm not very sure. So let me replace to make sure. The height is minus 0.7 over 3 times 2, because it's f of 2 plus 0.7. So it's minus 2 over 3 plus 1. You can use a calculator times 0.7. So it's 0.7 over 3 over 2. So it's 0.7 over 6. So it's 7 over 60. Yeah, and that's the answer in I. What's going to be the answer in II? Probability of x being smaller than 0.5. So 0.5 is here. So probability is going to be this area here. You can treat it as a trapezium. So what it was going to be, AII. So if you look at it as a trapezium, yeah, the height of the trapezium is 0.5. The big base is 0.7. The question is, what is this base? So in the function f of x, I'm going to replace x by 0.5 to find y. So minus 0.7 over 3 times 0.5 is 1 over 2 plus 0.7. So it's 5 over 6 times 0.7. So it's 35 over 60. Yeah, I can cancel a 5, so it's 7 over 12. So that's 7 over 12. Yeah, I recommend to get either decimals or fractions. So in question II, the area of the trapezium is big base plus small base times height over 2. And that's going to be your answer. Same for question B. We're using areas. Yeah, we can find the probabilities.